Greetings of the day to all. I am Shikha Kansal and we will be talking about theories of probability as it is the precursor for the more detailed topics that follows. What is probability? What are the different theories of probability? How to use probability? What are the formulas which we will be using in probability? We will be studying under theories of probability. So, as to why we are using probability. A statistical method discussed so far, which we have discussed till now, are helpful in summarizing sample data knowledge about the entire population or process. The things which we were doing, we were talking about the whole population, we were talking about the whole process. However, the decision makers often come across some degree of risk while selecting a particular course of action or strategies to solve a decision problem involving uncertainty. When we talk about uncertainty, it is probability. It is because each strategy can lead to a number of different possible outcomes or could be results. So, it is necessary for the decision maker to gain knowledge of concept of probability, probability distribution to choose in a course of action to arrive at an optimal decision. Basically, what is probability? When you do not know probability or when you do not know what is the chances of occurrence of an event, you need to have the knowledge of probability. Probability is basically when we are trying to find out what could be the outcomes, what could be the chances of occurrence of any of the event of we can say of the uncertainty of the process of any of the thing which we want to find out is basically probability. So, before discussing as to what is probability in detail, we should know what are the different things which gives us a clear idea of about the concept of probability. The first is random experiment. What is an experiment? Why it is random? An experiment basically it is also called as an act, a trial, an operation or a process. It is an activity that leads to the occurrence of one or only one of the several outcomes that is not predictable until the completion of the experiment is called as experiment. Fine. All the possible outcomes can be listed in advance. For example, if I have a coin and I want to find out whether head or tail will come. So, I know that only head and tail can come and there could be no combination of head and tail. I am repeating, if I have a coin, that coin can have either a head or can have a tail. So, I know that the coin can either give me a head or a tail, but I have no combination, I have nothing as head and tail on a coin. So, this is what is a third point saying all the possible outcomes can be listed in advance. This is the possible outcome of my tossing of a coin, either I can have a head or a tail. So, these are the random experiments which we are doing and they can be repeated. We can repeat them. For example, if I toss a coin and I get a head, but I wanted a tail, so I can just repeat it. So, I was knowing all the possible outcomes can be listed in advance, first thing, and the second is the experiments which I am doing, the tossing of the coin which I am doing, they can be, I can repeat that in order to get what I wish to. The same outcome may or may not occur the other when I am repeating it. For example, as I have taken the example of a coin, if first when I toss the coin first time it came out to be head, it is not necessary that when I toss the coin again it comes out to be head, it could be tail as well. So, first thing I know what will be the outcome, I can also repeat, and it is not necessary the outcome which occurred the first time will occur the second time as well, or the outcome which occurred the second time will also occur the third time as well. The variables, the variations among experimental outcomes is due to uncontrolled factor are called as random variations. That means, this variations could make the can make the decision biased. The variations which are there during the experiment, they can even make this experiment as biased experiment. Each random experiment may result in one or more outcome and is called as event and is denoted by a capital letter. We can use any capital letter, we can use A, capital A, we can use B, we can use C or any of our wish. So, random experiment is nothing, random experiment is basically you are taking, you are seeing, looking at the situation and you are just using that situation to find out it's an act, as told you, it could be a trial, it could be a process in which you just want to see what could be the outcomes, what could be the results, what and I can even repeat those results. I will be discussing these things with taking small examples, so that the idea of these random experiments could be clear, or could be the idea of event could be clear, as I have told you. So, if I am talking about an experiment, taking a small example of a coin, as we have already, or we can talk about a dice as well. A dice which has 6 faces, has 6 numbers on different faces. So, when we are throwing a dice, that throwing of a dice is an experiment. The different face values, that is 1, 2, 3, a dice has different values on different faces. So, the answer could be 1, 2, 3, 4, 5, 6, but we cannot have 7, because dice has 6 faces and the values which are given on different faces 1 to 6. So, first thing, all these possible outcome I already know, I need not to ask, I need not to tell, and I already know that these when I am throwing a dice, I will have one of these outcomes from 1 to 6. Now, if I wanted a 1, for example, when we play Ludo and we open the game by, if 1 comes, if 1 doesn't comes, then I'll ask for another chance, that I want one more chance, I want to throw it once again, so that I can see whether 1 will come or not. So, I can repeat it as many number of times I wish to. The third thing is, if in the first throw 5 came, it is not necessary that the 5 will repeat itself the next time, in the next throw. And if the dice has 6 number twice, that means this dice is biased. So, in that case there are variations, and that is called as a random variation. These are events. 1, if I am throwing a dice and it comes out to be 1, then that 1 becomes the event in throwing the dice. If it comes 2, 2 becomes the event, and it is denoted by a capital letter, any capital letter. For example, if I say A is equal to, I use a curly bracket to write down my events and I separate them by a comma. So, I put 1, could be 2, what could be 4 and so on. For example, 3 times I have thrown the dice. This is how we write down about random experiment. Now, the outcomes or the events or the observations, these were the outcomes or the events or the observation when we are talking about of an experiment may be expressed in numerical or non-numerical values. Why it is numerical and non-numerical? When we talk about numerical, then what does that mean? Numerical means, for example, when we are talking about measuring of blood pressure of group of people is numerical, because measuring of blood pressure gives you a number is a numerical. There are 5 people who got normal blood pressure, that is 90, 120, 90, and there were few more people who got less blood pressure, could be any. So, this is the numerical data which we are obtaining. Whereas, if we talk about counting the number of arrivals at a service window, counting of number of people who are coming during this duration at the service window, counting means how many people have arrived. So, how many gives you a specific number. So, it becomes a numerical data, a numerical outcome. Whereas, if I am tossing the coin to see head comes or tail comes, this observing or this tossing of the coin, this observation becomes a non-numerical data. But if they say how many times I have tossed the coin to get what I wish to, is how many gives you a numerical data again. If I want to see if the payment is made whether cash or check or in kind, is a non-numerical data. But if I want to find out how many customers gave the payment in cash or kind or check, that is a numerical data. So, when we are talking about how many, so how many gives you a number, whereas when we are talking about observation, then it is a non-numerical data. In all such cases, the outcome will not be known with certainty in advance until the experiment is not over or not complete. So, we have to complete the experiment first, and then we can only finalize the result. Now, in this, what is the sample space? The second thing, the first thing we talked about random experiment, and the second is sample space. What is the sample space? It's the set of distinct possible outcomes or the simple events for a random experiment is called as a sample, is called as a space or event space, provided two or more of these outcomes do not occur simultaneously. Each random experiment is resulting into exactly one of the outcomes, and third, it is represented by capital S. So, sample space also starts with S, therefore, it is also denoted by a capital S. For example, if we have two coins, and we want to toss them and we want to see what could be the outcomes. In the first row, on the first experiment, when we are doing, this could be head, or it could be head-tail, or it could be tail-tail, or it could be tail-head. These are the four possible outcomes which we can have. So, each one of this is called as the event. All of these is called as, this whole observation, this whole event is called as an experiment. Whereas, what is sample space? Sample space is the combination of all the events which we are having, separated by comma, are called as the sample space. So, what happens here is, until unless we do not know which coin is heading, which coin is showing us head or which coin is showing us tail. So, what we are supposed to do is, both the coins are same, both the coins are 1 rupee coin or any other coin. So, we have four different outcomes which we can have by tossing the two coins. Either it could be head, either it could be head tail, it could be tail head, or it could be tail tail. We have jotted down here the four possible outcomes. Simple events could be E1, E2, E3, E4, and when we are writing them in sample space, we are supposed to just put them in the curly brackets along and separated with a comma. So, sample space S is equal to bracket E1, comma E2, comma E3, comma E4, and even we can write it down as S is equal to head, comma head tail, comma tail head, comma tail tail. This could be another way of writing the sample space. Now, moving ahead, what are the different types of events? What are the different types of events? There are many different kinds of events which we will talk about, but before doing this, a simple possible outcome or a result of an experiment is called a simple elementary event. Simple or elementary event. An event is, what is an event? An event is a set of collection of one or more simple event of an experiment in a sample space having a specific common characteristic. What could be the common characteristics now? Common characteristics could be, both are the coins. We cannot take a coin and a dice. We cannot take a dice and pack of 52 cards. So, the common characteristics is both are having head, both are having head and tail as combination. So, this common characteristics has to be there, otherwise we cannot compare two different coins or two different things which we are taking as basically we can talk about experiment. So, an event is a set of collection of one or more simple event of an experiment in a sample space and having for a specific common characteristic. For example, more than 5 customers at a service facility in an hour is one example. Now, here we are talking about more than 5 customers, we can talk only about the customers, we are not talking about anybody else. Now, second example tells you the collection of head tail, tail head, etc., as we have used in the earlier question. So, this is one type of event, they have the common characteristic. We are talking about customers, common characteristics, all are customers, we are not talking about the other people. Now, customer, we know who are customers. Now, the second is we are talking about 2 coins being tossed twice. So, these could be the types of event. In the same manner, we have different we have 6 different types of events: mutually exclusive events, collectively exhaustive events, independent events, dependent events, compound events, equal likely events, and complementary events. Now, moving ahead, what are mutually exclusive events? If 2 or more events cannot occur simultaneously, if 2 or more events cannot occur simultaneously in a single trial of an experiment, then such events are called as mutually exclusive event or disjoint events. We can also say no events are mutually exclusive if the occurrence of one of them prevents or rules out the occurrence of the other. For example, the number of 2 and 3 cannot occur simultaneously if I roll a dice. Therefore, the set of event A1, A2, A3 and AN till AN is mutually exclusive if A1 or we can say AI intersecting with AJ is a null set, Now, we can also say if I have a coin and I want to throw a coin, if I want to just see what will have, if I have just rolled just throw a coin, I have 2 possibilities, either it could be head or it could be a tail, but it cannot be head tail or tail head. So, this is not possible, they are mutually exclusive events, either head can come or a tail can come. If I talk about mutually exclusive, then mutually exclusive also means when the other thing cannot repeat itself, cannot come until unless you will roll it or you will experiment it again. So, that is why we have said we can also say 2 events are mutually exclusive if the occurrence of one of them prevents or rules the occurrence of the other. For example, if I am throwing a dice and I have 1 to 6 number which can come on any of the face which is on the upside, then we can say if 1 has come, obviously if 1 is present on the upper screen of the dice, upper face of the dice, then obviously the other number cannot repeat. Therefore, the other numbers are mutually exclusive, either 1 could come or 2 can come or 3 can come. We cannot have 2 numbers on a single dice at the same time, but we can have 2 numbers on dice if I have 2 dice and I am rolling 2 dice simultaneously. So, on a single dice I cannot have 2 numbers at the same time, so they are mutually exclusive. All the numbers are mutually exclusive when we are talking about a dice. Next comes collectively exhaustive events. What are collectively exhaustive events? A list of all possible events that can occur from an experiment is said to be collectively exhaustive events. All the events which can come, for example, they are collectively exhaustive events. A list of all the possible events that can occur from an experiment is exhaustive. That means nothing else can come. For example, if I am rolling a dice, and I know my possible outcomes can be 1, 2, 3, 4, 5, 6. So, all these numbers which can come while I am experimenting, while throwing a dice, they are mutually exclusive events. They are collectively exhaustive events. They are collectively exhaustive events because they are the ones, they are the possible outcomes which can come. They are the possible events that can occur from an experiment are called as collectively exhaustive events. Symbolically, a set of events A1 comma A2, comma A3 till AN, as I have shown here, is collectively exhaustive when the union of these events is identical with the same sample space S. That means, if I have two coins, collectively exhaustive means this can have this could have head and tail, and this could also have head or tail if I am tossing them twice. So, collectively exhaustive events could be head head, head tail, tail head, tail tail, if I am tossing them 4 times collectively. So, they are collectively exhaustive events. For example, the number 7 cannot come up the uppermost face during the experiment if I have 1 dice, but yes, 7 can come, the addition of the 2 numbers can add up to 7 if I have 2 dice, I am rolling 2 dice. But if I have only 1 dice, 7 number cannot come, because on the faces we have only 1 to 6. So, the number 7 cannot come upon the uppermost face during the experiment of rolling a dice, because the numbers uppermost face from the sample space 1 to 6. But what if I have 2 dice? I can have, in order to obtain 7, I can have 6 plus 1, I can have 4 plus 3, I can have 3 plus 4, and I can even have 5 plus 2 or 2 plus 5, but I need to have 2 dice. So, this is all about what is exhaustive events. Exhaustive means you are supposed to exhaust for all the outcomes which can come. We are supposed to know what all can come. So, they are called as exhaustive events. Next comes independent and dependent events. Independent is what? Independent is when 2 or more events does not affect, when 2 or more events does not affect and are not affected by other event, is called as independent event. For example, if I am rolling 2 dice, the result on the 1 dice is not affected by the result on the other dice. Yes, they are not connected to each other. For example, if I have a pack of 52 cards, if I am just picking out one card out of those 52 cards, that is not affecting my another picking of the card until unless I am not placing it again, until unless the first card which I have found, which I have picked, I am not placing it again. So, they are called as independent events. For example, the outcome of successive tosses of a coin are independent of the outcome in the preceding toss. Yes, obviously yes. Why? Because if I am tossing a coin and I am getting head, I am again tossing a coin if I am getting tail. My first head which came, it is not affecting the tail which has just came in the second toss. So, the first toss and the second toss, they are independent, they are not affecting each other. So, these are called as the independent events. Increase in the population, if in percentage in India, is independent to the increase in population in America, or we can say increase in the production of wheat in America. Both are different, we cannot correlate these two, we cannot put them together. So, they are independent events, we cannot, they are not dependent on each other. Whereas, what are dependent events? When 2 or more events they occur and they affect and they are getting affected by one another event, is called as the dependent event. For example, if I am drawing a card, say a queen, if I want to draw a card, a queen from a pack of 52 cards, which we have, and I am not placing it again, I am not replacing it. So, the chances of drawing another queen is it goes down, it is diminishing, or it is subsequently, if I am drawing, it is the chances of drawing a queen is reduced. So, this is called as a dependent event. For example, if there are 10 students in the class and there are 4 activities which are going on in the class, those 10, out of those 10 students, I wanted one student to participate in all the 4 events, and whether is it possible for the one person to participate in all the 4 events when he is actively participating in one? No. So, this is called as a dependent event. The also depends and the events also depend. So, what happens is when we are not placing, when we are not replacing it again, when we are not if we are picking out one, we are not placing somebody else onto its place. So, it becomes a dependent event and the chances of occurrence of that event becomes less. So, this is dependent and independent event. Next comes what are compound events. Compound events are two or more events are said to be compound when these events they occur simultaneously. They occur simultaneously, they are called as compound events. These events may be dependent or may not be dependent, they are compound events. Equal likely events is a very hairline difference between the two. Two or more events are said to be equal likely when each of these has an equal chance of occurrence, is called as equal likely event. That is, one of them cannot be expected to occur in preference to the other. For example, each number may be expected to occur on the uppermost face of the rolling of the dice n number of times. You cannot control any number can come. For example, if I have pack of 52 cards and I am drawing one card, any card can come. If I am not, if I am putting it again, any card can come, either a ace can come or a joker can come or we can say a queen can come, any number. So, every number which is there in the pack of cards, it has equal likely events to come. For example, if we have a coin and we are tossing a coin, that means either head can come or tail can come. We cannot control a tail or a head, and tail and head both the faces have equal chances to occur. So, these are called as a equal likely event, whereas compound event, as we have discussed, compound events are two or more events which are said to have occur at the same time. They are supposed to occur simultaneously, they are called as a compound event. Now, next comes as complement event. What are complement event? Complement events are, for example, if my population, that is universe, consists of 1, 2, 3, 4, 5 and 6, but my first sample it has 1, 4, 5. Then what is a complement? Complement means if E is the subset of sample space, then its complement denoted by E bar contains all the elements of sample space that are not the part of E. That means E complement, that is complement event E bar, is equal to your sample space S minus E. That means my complement becomes E bar is equal to, we do not have 2, then we do not have 6 and we do not have 3 as well. So, this becomes my complement. All the sample elements not in E. I am repeating again. If E is the subset of sample space, if E is the sample space, if E is the subset of the sample space U, for example, then complement denoted by E bar contains all the elements of the sample space that are not the part of E. So, my E had, another example, if you had 1, 4, 5, then we have 2, 3, 6, then the complement says this is complement, this is E. All the numbers, all the elements which are not the part of your subset is called as the complement events. This was all about when we talk about the basics of probability. Now, what is basically a probability? We will be studying, although we will be studying it in the next presentation, but exactly what is probability, just have a definition here. A probability is nothing but we are supposed to find out at what are the chances of occurrence of an event is probability. The chances of occurrence of an event is probability measured between 0 and 1 inclusively of this, the likelihood or the chances of occurrence of uncertain events. There are three approaches in which we will be studying the probability. One is classical approach, one is relative frequency approach, and one is the subjective approach. This is all from my side. Thank you.